is AES symmetric. This is to show, our goal here is to show confidentiality. You get only someone with the password can read the file. That's what we are about to do now. So for us to do that, the first one, we have to create a test file by saying echo space my secret is that I love coding / programming. So we create the txt file. So this is how we do it. Remember, this text must be inside a string. This is a string. This is the opening string, while this is the closing string. So make sure you open and close it, then hit enter. Now we have a student record.txt. After that, we have to encrypt it, like to lock the box. We have to encrypt it with AES 256 CBC using OpenSSL. So how do we do that? We say OpenSSL space ENC space minus AES minus 256 minus CBC space salt, that is minus salt space minus in. Then we call that student record.txt file we created earlier by saying student underscore record.txt. Then for the outer part, the output should be student underscore record dot enc, that's encryption. Remember what we are doing now. This is the second step. Encrypt with AES 256 CBC using OpenSSL. So that's what we are doing now. So we hit enter. It's now requiring for a password. We need to create a password for this. You understand? So that, remember what we said earlier. We said our goal here is to show confidentiality. You grab, so that only someone with the password can really access the file. Just like if I'm sending you a WhatsApp message, only you that I send the message to can be able to access the message. There's no other third party can be able to access the message or see the message. So that's what we are doing here. So we create a password for the encrypted file. So we use something like group 28 as our password. So for confirmation, we say group 28. So we have already created a password for that. Then the step 3 is to decrypt the file. The step 3 is to decrypt the file. We also use that OpenSSL for the file decryption. You understand? So for us to do that, we say something like OpenSSL ENC AES minus 256 CBC minus D minus N. Then inside the N, we have to call that same student record.enc we created earlier. We're saying student underscore record.enc. Then for the output, we call decrypted.txt. Then hit enter. Now it's requiring for the password we created earlier. Why encrypting the student record with OpenSSL. So the password we used was group 28. So for us to check if the decrypted ones and the encrypted ones, if they match, we have to use the cat to check it. So by saying CAT decrypted text, decrypted.txt. So as you can see, this is our decrypted text. Now we have to hash it so that we can get the fingerprint of the text. So for the hashing and integrity checking, the goal here is to demonstrate the integrity and detect even a tiny change, like any change you can make in the file you just encrypted. It will automatically change the fingerprint. So we first of all create a random file for the hashing by saying echo. We say something like download this important software. Then you close the string. This should be in okay, let's create another file for this one. We say something like my file.txt and hit enter. Now let's generate the SHA-256 hash for this particular one we just created. So to take the fingerprint, we say SHA-256 sum space name of the file you just created, which we named my file.txt. As you can see, this is the fingerprint. This is the fingerprint of this my file.txt. Now if you like, you can copy this fingerprint and save it somewhere so that you can compare it with this one we are about to do now. So we have to modify the file slightly, like to change a single character or more than. Yeah, so how do we do that? I'm coming. Okay, let's say echo space download. As I'm adding that same text that is inside my file.txt. So download this important software. Then I'll add something like I'll add something like triple dots. Should I add another thing? Let me add something like now and close the string. Now let's direct it to our file.txt. So So what I did here is I'll add a comment. I'll just say I added triple dots and now. And now. So I hit enter. Now let's check the fingerprint of my file again by saying sh this is it space my file.txt and hit enter. Now as you can see, the first fingerprint is very different from the second one, but it is the same file. Remember, it is the same file, but we edited the text inside the same file. Do you understand? We edited the text inside the same file, so that's why the fingerprint has to change. You understand? You can open this with the text editor where the file is being saved. You can open it. You must not use Kali Linux to go through this process. You can just open your text editor and check it. You understand? So now when you are done with this one, you just screenshot with Windows Shift S. So you screenshot, select the environment you want to screenshot and save for the presentation. Now the third part is the public key encryption, which is or the secure messaging, which is the GPG. So the goal here is to show confidentiality and authenticity using asymmetric cryptography. So the first one we have to do is to generate our own key pair. So to generate that one, we have to clear this environment first. To generate it, we will say GPG, then we add a full generate key flag, which is full generate key. Then we hit enter. Now we choose the first one, which is the RSA and the RSA and RSA. Then but is also the default, so we hit 1 and select. Then it asks the key size. Which key size do you want? We want 4096 bits long, so we say 4096 bits. Now, but you can also select 3072 because this is a demo, so it's fine for demo. Now, the expiry date, we select 0. 0 is the key does not expire. So is this correct? Yes. So it's now asking for our real name. So our real name is Kelvin Henry. Then the email address we use is group28@example.com. You can put your own personal email here. But I don't want to use my own personal email because this is a demo, not this is just a guide on the real project, not this one. Then this is a comment. We say something like getting my hands dirty in cyber security projects. This is my own comment. You can add your own comments. So this place they ask change, they said change N, that is name, C comment, E email, or O okay /Q, that is quit. So we will select O so that we can say that this is okay. It's now generating okay. We have to create a passphrase for our encrypted text. So which passphrase should we create? And mind you, you need a very, very strong passphrase here, but I'll just use a random one, which is group 28. Group 28. So as you can see, you are seeing the message warning here. It says you have entered an insecure passphrase. A passphrase should be at least 8 characters long. So you can select to change the passphrase, or we take this one. So since this one is a demo, we have to take this one anyway. So let's wait for it to generate. So this will create a public and private key pair. So when it's done, this is it. So it just created a public and private key pair. So let's list it by saying GP. Okay, let me clear this environment first. Let's list it by saying GPG. Then we use list key flag, which is minus list keys. As you can see, this is our public key. This is it. Then this is our UID. This is our UID. Our name, our email. Okay, this is the previous one I did with my own personal email, while this one is the current one I did. So this is the public ID here. Then this is the UID, which is my real name, the comment, and the email address. So then the next one is to encrypt a message to someone else using their public key. So how do we do that? We have to simulate two people, like me and one of you guys. You understand? So for us to do that, we say we have to export our public key to share. So we say GPG. We use export flag, which is minus export -a. Then my real name, which is Kelvin Henry. Then my public key, which is this. I don't understand. Is it to create, add the public key, or to create a fresh? say something like my public key. Or my public dot key. My public dot key. Hope I'm getting it right. So you as the teammate or the person receiving the email from another end. So I will open a fresh new terminal so that I can receive out the email message. So by saying GPG, we have to import. We use the import flag, which is -- import. Remember, in this previous terminal we used export flag here, but in this current terminal we are using import flag. So the export flag is the sender, but the import flag is the receiver. Then remember, the name is your public dot key. So we say your public dot key and hit enter. Your public dot key. Oh, it should be this key. Okay, my public, not your public. Sorry, it should be my public dot key. Okay, as you can see, this is it. This is the key. That this is our UID. Okay, this UID is the previous one I did before. Then this current one I'm doing is this one. So this is the UID of it. So this is the key. Then the name, the comment, the what's it called, the email address. So you as the teammate encrypts a message for you, me and you using my own public key. You grab. So this is it. We say echo hi. This is a secret message for you. Then we close it and create the txt file .txt. Then enter. We have to encrypt it by saying GPG encrypt. Recipient is my name. I will say Kelvin Henry. Then message .txt. So we hit enter. So it says file message.txt.gpg exits. Do you want to overwrite? Let's overwrite it. Yeah, so this produces message.txt.gpg. So now the message we just typed now is encrypted. So for you to decrypt it, only the private key, like only your private key, can decrypt this message I just encrypted now. So the next part is to decrypt the message I just encrypted now. If you go to the template, you see decrypt the message using your private key. So back on my machine, this is my machine. So I will say GPG space decrypt. Remember, this one is encrypt. Then I am the one receiving the message, so I have to use the decrypt flag. So decrypt, then message dot txt dot gpg. Then you should go inside the recipient. Sorry, inside the received dot txt. Now it's requiring for our passphrase that we created earlier. So our passphrase was group 28. As you can see, I have decrypted the message he sent. Someone else sent to me using my own private key. He sent it using his public key. I decrypted it with my private key. So if you look at the screen, you will see the decrypted messages. So the next one is the digital signature. That's the authenticity. We have to sign a file to report it, to prove it came from me, like the file is coming from me. So for us to do that, we say echo. Inside the string, we say I approve this document. Then you close your string, direct it to document.txt file. So it will look around inside our Kali notes. If you don't have document.txt file, it will automatically create document.txt file. Then inside the document.txt file, it will have I approve this document as a test. So you hit enter. Now we say GPG space, we use sign flag and the local user flag. Local user, then our name is Kevin Henry. Then we are referring to the document.txt. Now we have it in the document.txt. So this we create document.txt.gpg. You understand? So this is a signed file, just like in your personal computer. You can zip some files. So that's it here. So to verify, we will say GPG. Then we use verify flag, which is verify. Then document.txt.gpg and hit enter. As you can see, signature made Tuesday 2nd June 2026 by 15:41 p.m. You understand? So this is how it's the issuer. I used this key. Then the issuer is me. That's the kevinharry619@gmail.com. Then this is the UID. That's the user identification. So if you do your own and it does not show good signature from this so person, then you write your comment. That's if you provided the comment previously. Then your email address, then you have to do it again. It must write good signature. That's if the file is unchanged and the signer's public key is trusted. So my own public key is trusted. I don't know about your own. So this one talks about protection, encryption with public key, that is confidentiality, and digital signature, that is authenticity and integrity, that is signature breaks if file is modified. That is signature breaks if file is modified. I think that's all. But the fourth one, I think the last one, is it says choose the easiest to implement and demo. That's the scenario simulation. It says we should pick one. Then the option A says file verification system, that is integrity, using the hashing steps from deliverable. Then the scenario, your company provides a critical software download. You publish the original SHA-256 hash on a secure web page. The simulation is create a software file, example app.exe. Then the second one, compute its hash to original.hash. Then pretend an attacker modified it. That is, you change the byte to a new file which is fake underscore app.exe. Run the SHA-256 sum space fake underscore app.exe. Show it. Okay, show it doesn't match. Okay. Then the fifth one is explain that users can verify the file hasn't been tampered with by comparing with the published hash. Then you start your screenshot and everything, you know. So I think we can stop here for today. That's it. I don't know if you have any other thing to add, or if you feel like I didn't add anything, just write me a message so that, or just drop your own. I believe all of you have done your own parts. This is me doing my own.